today. We've got an excellent conversation coming up. Kyle is working on the machine learning platform team at Etsy. He's a software engineer there. We were just talking before we hit record about how he's been burying himself in coding so much that he can't even play his guitar. He has not found any time to play the guitar in the last couple years, but that is good for us because we don't want to talk about guitar today. We want to talk about MLOps and everything under the sun when it comes to MLOps. And I'm excited to get into how you see the current state of what is happening in this space, Kyle. I think it would be interesting for us to start with your path from being a data analyst to a data scientist to an ML engineer and then a platform software engineer. What did that look like? And what kind of hurdles did you have to overcome as you jumped from one to the next?
Yeah, definitely. I would say it's a somewhat non-traditional path. I'd always like to say, I've said it a bunch of times, that I tripped and fell into the data science space. So I was actually finishing up my master's in molecular and cellular biology when I got this random job as a data analyst. And my job there was to teach myself R and Python to analyze the data that we had at this biotechnology company. After generating some interest in the data space there, I ended up kind of fostering a love for data and data science. I was doing some unsupervised machine learning. Got super interested in that, went to a boot camp here in New York City. So I did the whole boot camp route. Then after some odd jobs, ended up as a data scientist and then machine learning engineer at Pfizer. So kind of from more and more analytical stuff and statistical stuff, slowly more towards the machine learning driven path. And now I'm, purely basically a software engineer on the infrastructure side, so very back end.
There's some funny stuff happening right now in the MLOps community Slack, which is a group of people that decided data scientists need to, or they want to share horror stories of what they've had with data scientists when it comes to the code that data scientists write. I want to get your take on how hard was it, or what were some things that helped you along the way when you were learning to go from that data analyst to an actual full-fledged engineer?
Yeah, that's a great question, because there is a huge difference in the required skill set and the expected quality of those skill sets. Obviously, I didn't come out of school with a software engineering degree and feel like I really lacked some of those fundamental CS basics, just from data structures and algorithms that aren't as important. I mean, maybe not even as important in a real software engineering job, but really build the base for all of the code that you learn beyond there. And so it's kind of been funny, learning what you would call, I guess, more advanced data science code, but then having to go back to CS 101 on my own and in my own time to also build that basis on the side.
I've actually had a very similar experience. So I studied bioengineering in my undergrad and master's. And, I think sometimes I'm like, man, if only I had an undergrad CS degree. Not that I would, change what I studied, but if I could just tack that on really easily, it'd make my life so much easier.
Yeah, no, tell me about it. It's I'm very happy with the path I took, but I just always wish, I'm wow, I wish I'd just taken more classes, had more of that knowledge, or at least, paid attention the one time I took a CS class.
Yeah, exactly. I just want to be in those freshman and sophomore classes. That's all I need.
Yeah, exactly. That's what I'm missing.
Got it.
In this production code channel that we have, there was a pretty awesome question that came up, and I want to hear your take on this, Kyle. It's asking about if you were to build a SaaS app right now with some heavy ML services from scratch, what languages and frameworks and libraries would you use for the back end? If you weren't under the gun for time, you had your abilities that you're currently using, and you could really engineer this stuff the way that you wanted, how would you go about doing that?
That's a great question. I guess I'm sure I'll give different answers throughout different points in my career. For a software, for just a language, I might just have to go with Python just because it's so ubiquitous. It's easy to use. I can write it quickly. I can test it quickly, like easy to write for. I'm also like writing a lot of Scala lately, and it's awesome, high performance, but it's much more difficult comparatively to like do the things that I want to do. Just because Python is so much support for so many different things, especially within the machine learning space. But like, yeah, I mean, at the end of the day, I feel like I'd end up writing more YAML than anything else. So, it'd all be templated.
Yeah, the YAML thing is interesting because, I think we both, I work in ML infrastructure as well. And, it's like, sometimes I'm like, it's so simple. It's so templated. It feels like, I'm just doing like almost like stenography work where I'm filling out a form. Yeah. But there's so much that is based on that. It kind of blew my mind recently. Like when I was really diving into some like CI concepts and trying to figure out like, okay, how do I make this whole like CI pipeline process scalable for sort of like machine learning repos, et cetera. I was like, man, this YAML stuff, it's just, it's what I could do all day, but it's so, I don't know, replicable and crucial to the workflows nowadays.
Yeah, it is also everywhere. I mean, like, I think it's like the Python of markup languages, right? It's like simple, it's easy to read, like just like colons and nothing else, no brackets or anything like that. But it's kind of but like kind of every tool is reliant on it. And it's cool. I mean, I like it. I think it's easy to read and use, and it's like a really nice introduction to a ton of different concepts where templating is key.
So I would like to ask you, what are your maybe top 2 or 3 tips in terms of working with sort of like YAML in general, YAML files and like the explosion that can happen that you would offer to beginners, especially data scientists who are saying, okay, I want to get into this MLOps jutsu. This seems important. How should I do it?
Yeah, for that, I guess it's a good question. I mean, like, find like a technology maybe that you're comfortable with. I think like I started with like Docker Compose, like just one step above like Docker files, like pretty simple, but you can do a lot with them. And there's like a really easy transition from there to like full scale in Kubernetes. I think the only like real second big tip that I have would be just like, no need to go light on the plugins for your IDE. I have like a rainbow indent plugin for VS Code that's perfect for YAML. You can just like see like where things are indented out to, and just let the IDE do the work. You don't want to like be trying to apply something and constantly getting like errors because it's not in the right format or not the right spacing, et cetera. It's super frustrating.
Yeah, I actually think tips like that are underrated. It's a great tip because I used to say this. It's like taking hard classes in college is way overrated. Like no employer is ever going to be like, hey, Vishnu, you took the hardest class for math in your sophomore year. We're going to give you a raise. Nobody ever does that, right? It's the same way with coding, right? Nobody ever is going to say, wow, you did it without any plugins in your VS Code environment. Like you were really good at this. And I think for beginners in particular, that's a hard bridge to cross, right? Because people in this field, in this data science field, all bright, ambitious, talented people who want to learn how to do things right. And I think Kyle and I are here to tell you that doesn't mean you can't do them faster and use tools to do it.
Ain't no shame in it.
No, not at all. Like, please take the easy way. Like, don't, don't try and do everything in Vim or something like that. You have all these tools available to you, and there's definitely no extra points for doing it that way, even if it, might save you once or twice in some random scenarios.
Well, speaking of random tools, do you have any others that you really like, or plugins or anything that you can share with us?
Let me see. Let me like, what's up in my Visual Studio Code right now? I'm a big Visual Studio Code fan. I definitely use that for most everything, kind of just like install plugins as I go. Big fan of the remote SSH plugin, do a lot of remote editing. A lot of the basic ones, they'll just pop up and be suggested as you're editing. And I'm like, I'm going to try this. This is great. I really love those.
Well, let's talk for a minute about this idea that you were mentioning before to me of like where you think the future of machine learning, data science, and even machine learning platforms is going, and how you're looking at the bigger picture, right now in the ecosystem of machine learning, data science, MLOps, and that whole climate, the current climate that we're in? Where do you see it moving forward?
Yeah, it's kind of funny, like, I guess, because I've seen it through a couple of different phases. So we started off in kind of data science was the super immature space. And that was it. It was just like a data science team, but there was no concept of like, at least formally, like MLOps and anything beyond that, and like the software engineering side of things. Data scientists, I don't know, felt like kind of isolated, siloed, and it was more so a lot of proof of concept pet projects and things that were then really difficult to get off the ground. And then we kind of came to this, MLOps space. It was like, okay, lots of these aren't making it into production. Why aren't they? It's because we don't have the operational tools and processes to get them there. We can't deploy these into production easily, or just the data science skill set isn't conducive to getting them there. Software engineers obviously know how to do this, but there's a disconnect between the two. That handoff was really, really tough because data scientists and software engineers just weren't speaking the same language. And now I think we're kind of there. A lot of like MLOps is, again, like, it's ubiquitous, it's everywhere, it's a buzzword. And it's awesome to see it like exploding so much in terms of from open source support to just the enterprise platform offerings. But even then, I think there's like, kind of a need for the step above that, which I would say is something like governance, right? Where you actually manage your MLOps and you have I'll focus on some of the more important non-functional requirements. Something like observability, right? Which is like, like a software term. It's not something that like inherently, I think, has been phrased a lot in like MLOps, but like it's something that is observability and visibility, I think, are some of the most important things that you can have. And that is kind of that next phase of governance, how you manage and like control all of those operations and processes that you have, and like how much visibility you have over them.
Yeah, I agree first and foremost with your overall description of the maturity and the process in the entire space. I think what you landed on that I think is really interesting is I realize now that a lot of machine learning platforms and a lot of this MLOps and overall platform engineering work has kind of come out of a frustration. It's really frustration driven in terms of that handoff not necessarily working, in terms of, groups speaking different languages, having different objectives, and enough people kind of saying, man, this sucks, and I think that's the iteration of this whole space that we're in right now, where a lot of people are saying, okay, this doesn't have to suck. And going forward, the way we're going to see it is it's going to move kind of from an efficiency to a capability, right? I think that is kind of where I think those things like observability, visibility, being able to like scale your whole stack around your model easily, the same way that you do like infrastructure as code in another regard. You're going to have your model as code. And I think that's already happening, right? With OpenAI basically just exposing GPT-3 as an API and saying, yeah, there's models behind this fence and, come use it. I think more companies are going to be able to do things like that. So, I think the interesting part here for me, and I'm curious to get your thoughts, is I think that part of visibility and really understanding the way things work with respect to the model and, data drift and how the question of robustness, that's where I find that maybe the research isn't quite there yet. It's like we're kind of waiting to see how to do that the right way. What has been your experience with that question? Do you think there's maybe some heuristics we can use, or do you think we still have a little bit further to go?
I think I agree that we have a little bit further to go. I think it's kind of funny because, I mean, I'm sure it's been said on this podcast even a bunch of times, but the technology exists somewhere. It's kind of like how and when we apply it. I feel like a lot of the decisions that I've had to make on a day-to-day aren't like, oh, I need to like build an entirely new technology. It's like, okay, what is the best way to apply this for a machine learning specific operation? A lot of things in the machine learning space do map directly from software one-to-one, I think, at least. I think there's a lot of parallels and things that we can just say, hey, this is working in software. We should definitely be doing this in machine learning, which is also software. But there's also some things, like some considerations. Maybe it's data drift, model drift, Maybe it's like the inherent nature of trying to serve a stateless model at scale or something like that. But I think that there's some considerations there that aren't really fully fleshed out, and no one has had the time or maybe even the inclination to kind of go through, like you said, and research like, okay, these are the most efficient ways to monitor for data drift or model drift or something like that. And we don't fully know what the best way to go about that is. Once you get to that level, it is kind of unknown territory. Even if you could feasibly implement whatever you want, you don't know what the best thing might be to implement for your use case.
Yeah, I see what you're saying there. And I think this is where I'm hopeful of all of our awesome vendors that are in the MLOps community Slack and that are helping us figure this out together. I do think that there are some interesting work that they're doing. And, when you have these sort of, it's kind of like you have your deep companies and then you have your broad companies, right? And like when you have your deep companies, like, an Etsy or a Pfizer or, Tesseract, which is my company, or any other company, we're trying to figure it out in a particular vertical. But then when you have these broad companies, like Fiddler, who came on our, our podcast recently, they're figuring out across a whole bunch of different verticals. And they're kind of saying, okay, this is what works everywhere. This is what aspect of our monitoring or observability. And that, I think, hopefully that'll trickle out. I guess one of the questions go ahead.
Do you think it can be that? Because it feels to me like there's so many different use cases and there is no standardization right now. And it's really hard to say like, this is what works in everywhere, right? Like, do you think that will ever be a thing, or is that something that it's going to have to be like specialized and customized or bespoke and every time you want to implement it?
I would kick it to Kyle here and say, you've been in consumer, you've been in healthcare, you've been in bio. I mean, what has been your experience with that question of what's abstractable and what's not?
Yeah, it's definitely a hard question to answer. I mean, because it is dramatically different. And I don't think that we're at least at a place where like one size would be able to fit all. I think like the key there is kind of what I think a lot of like the really good vendors out there are doing is like making themselves integration first platforms. Like, all right, we're going to like see what the most common use cases are. We're going to say like, we're going to solve 80% of your requirements, but we're going to allow you to build that, that remaining 20% because our platform is so flexible and integratable with all of the systems that you might happen to have running. And so I think it's really about, I think there are a lot of commonalities, but the subtle difference is if you try and build for everything, then you would fail. Yeah.
Yeah, I see what you're saying there. It's like if it's like taking on too much in a sense, and it's like you end up becoming. It's hard to balance all of that, and if you have that sort of flexibility inherent to integrations rather than trying to custom engineer everything, it becomes a lot easier. I kind of have this question just around like this notion of machine learning infrastructure and platform. Like, you have had this transition from like, let's say, user of the platform, loosely speaking, to like architect of the platform, right? And I think there are a lot of people in our community who feel similarly, right? You start off because companies are hiring machine learning engineers or they're hiring data scientists, and then the machine learning engineer, usually one or two realize, wait, we should probably do this in a repeatable, scalable, maintainable way.
Yeah.
How did that realization come about for you? I would really love to dive into this.
Yeah, I guess it was just like probably the first time I went to take somebody to production, or maybe it was more so the second, right? Maybe the first time was just kind of like, all right, maybe this is just how it is. And then it was the second time I was like, all right, why don't we just do that? Like, but again. And I personally, because I didn't at the time, I guess, have the insights into what was going on like behind the infrastructure veil, I, probably didn't know the right way to interface with software engineers. And at the time, there was no common practice for that delivery of data science model to software engineer infrastructure. So yeah, like I think like a lot of people in the Slack, I probably like gained an interest in that side of things and applied myself there a lot. I've now tried to come back and say, okay, like when we build, a platform team, your customers are data scientists. Where do you meet them? How do you meet them? Like at what is your expectation of a data scientist? Like, what do you want them to come to you with? What do you need them to know? And then what is the expectation on what, you're supposed to provide them so that they can have the best user experience in your platform and deliver models as quickly as possible to production. I think that's, I think a common KPI for a lot of teams is like time to production for a new data scientist or something like that. And it's kind of like thinking about in the context of your company, your org, team, whatever, where do you meet the data scientist to best foster that relationship and best expedite that trip to production?
And
along those, oh,
go ahead, Demetrius.
Typical Zoom meeting. Yeah. So I was just thinking about the place and where the data scientist fits in on this, and how you've gone from being the data scientist or the customer and then actually creating it. And we talked a little bit about like the ability to know how to code and know this software engineering gives you so many advantages when you're a data scientist. And so I'm just wondering, and this is something that comes up quite a bit, is when you're a data scientist, you just stay in your lane and you focus on getting the most out of the model and really that's it? Or are you going into the platform and trying to make it better and maybe working with the platform team? Or if you don't have a platform team, are you trying to create that platform? Like, how do you look at that?
Yeah. And if I'm not giving direct answers, it's only because, again, one size doesn't fit all. It really depends on the data scientist, because I have met data scientists who are very stay in their lane and they want to like give you a serialized, model or something like that and be like, I'm done. That's what you get. And like, it's everything from there. And then there were people who are data scientists like myself who were like, this isn't enough. I want to understand, the platform. I want to actually like learn the things in that platform so that I can, iterate and improve them with platform engineers and learn that side of things. And I actually like software engineering better than modeling personally. It's more definitive and less frustrating in my mind. But yeah, I think like it's so highly variable. And I guess that's part of like being a platform engineer is like just being open to both. Like I've definitely worked with data scientists who really like to like learn Kubernetes or stuff like that. I'm like, yeah, I'll absolutely help you with that. I think it's cool that you want to learn that. And it's helpful overall for both kind of collaborating there. And there's data scientists who want to be hands off, and we have to meet them there as well.
Yeah, I think one thing that I've realized working at a startup, we have to hire a particular kind of people, right? Because working at a startup is risky and often very frustrating. And I think it's given me a sensitivity to that exact point that you have, which is how you build some of these tools really depends on the kind of people that you hire and the kind of people that come into the door and what they're interested in, especially at a smaller company like ours, or even some of the larger companies that you work on. I mean, I'm sure there is no ML team anywhere in the world, maybe outside of Fang, where it's like, 100 people, right? Most ML teams are very small. And so it's like, who do you have and what are you going to do with them?
Yeah, 100%.
That it ends up being day to day.
Yeah, maybe they're PhD, mathematicians and stuff like that. And that's, completely different from people who maybe came from a boot camp from a variety of different backgrounds or otherwise. And yeah, it's super, super variable. But I mean, yeah, that just kind of comes down to what we were, I guess, talking about earlier about data science still being so poorly defined and so in flux in terms of a definition of a domain and as a role and and everything.
Yeah, for sure. That level of variability, it's definitely it's a feature. It's a feature of the field that hopefully we'll get rid of over time. In this platform engineering realm, what would you say maybe the most interesting challenge is that you experience? And some things that come to mind are like CI/CD and like continuous training or data management, distributed training, orchestration. Like, what are the engineering challenges that really get you interested in this platform question?
Yeah, I've always really, really loved model serving for some reason. I don't know why. Like, maybe just because it's more of an instantaneous thing. It's like an API calling back and it works, and you see the result. Training for me, while like has a lot of very, very interesting engineering problems, it's always been frustrating to implement just because of some of the time constraints. Maybe you kick off the job 8 hours later, you're like, oh man, that failed. Like, gonna run again. So I've always found like the enhancements in performance, especially like now with so many like large transformer-based language models and stuff like that. How do we continuously optimize model serving to the point where it's feasible and actually like generates value to serve these models at scale? So I think that's like all of the challenges under that space are super, super interesting. And there's a lot of really cool open source and like enterprise serving frameworks now that are fun to play with.
And so let's say a community member were to come up to you and say, Kyle, you've worked at some great companies. You're an expert on model serving. How should I, my company wants to figure out a strategy for this. They told me I need to figure out what our model serving platform looks like. What are some of the things I should watch out for? And what are some of the tools you'd suggest? Anything that you would offer as advice?
Ooh, yeah, that's a great question.
Basically, free consulting. That's what we're looking for, Kyle.
Yeah, it would definitely depend a lot on the company. Like my first inclination would be like, if depending on the resources you have, just evaluate a lot of, the vendors out there. There's a lot of like really, really great tools coming out of a lot of different companies. I feel like so many different enterprise offerings just to have model serving, but it's also built as part of a larger experiential platform. Or there's even things that are more hands-off. For instance, like Selvin, I believe, just like an open source framework for deploying models in Kubernetes also offers like Selvin Deploy, which is, I think, their enterprise tool, which is more UI driven, but a nice way to like deploy and manage your models. I would say that like the technical aspect of serving is going to be easy, right? Like you have something like TensorFlow serving, you just train a TensorFlow model, get the Docker image, bam, you have an endpoint. But managing that and actually like getting to that governance level of how do you manage if you have 50 models, how do you keep track of those, and how do you manage those endpoints, make sure you're not wasting resources, being cost effective, maybe like role-based access controls. All of that stuff is like the real stuff that you have to watch out for in that space, because otherwise you just get this explosion of tech debt that is totally unmanageable. Yeah,
the nitty gritty for sure. So when it comes to this stuff, do you think about like when you're working on the platform and you're looking at the platform as a whole, do you have problems when it comes to like plugging in different pieces of the puzzle in the platform? Because one thing that I've heard many complain about, or just mention, maybe not complain, I'm projecting the complaints onto them, but many have mentioned how there's not really standardization yet, and you don't have an easy way to do the Lego blocks and switch out one piece for another piece. Have you found that to be true, and how have you dealt with it?
Yeah, I've definitely found it to be true to a degree. I guess it depends on the kind of like where you're at. Like, you're working with a lot of like monolithic in-house tools, or is your company very like microservices driven? I know, again, like a buzzword, but I think there are benefits to working with microservices. But yeah, like it's never as easy as plug and play, right? Like you're like, oh wow, like even if these things are like, even if you're told they're going to be Lego blocks, they're never Lego blocks. You spend like the first 2 hours trying to like cram two together that should go together, and it just like doesn't work for you. So I think, yeah, at the high level, I've definitely had issues, putting those pieces of the puzzle together. Even starting with the first piece of the puzzle, you always estimate how long a task is going to take in the machine learning space. You're like, all right, this will take me an hour. And then 2 days later, you're like, what is happening? Why is nothing working?
Why do you think that is? Because I've heard that so many times, like it's really hard to judge how long something is going to take in this space. And that's another reason why some people are really against doing sprints in the machine learning field, because it is so hard to judge.
Yeah, I mean, like I think like it might come down to how you do your estimates. Like if you're trying to like, kind of like throw stuff at a wall and see what sticks, in regards to like if I had to estimate building an entire ML platform, like offhand, I would have no idea, but I would probably double or triple whatever my initial estimate was. But I feel like it just kind of, comes down to agile, right? You just want to like take that and like start being like, okay, like what are the small pieces that I actually know how long they take? Or can at least guess, right? It's no big deal if you estimate something as a is a 2-point ticket turns out to be a 2-week thing, like it happens. It's always going to happen. But the better that you can break down that work into smaller pieces, the more accurate you're going to be. I think it's especially tricky in the ML space because you don't know how a model is going to do before you train it. I remember as a data scientist, people being like, how long until you get to this, this level of accuracy or like this level of acceptance? It would be like, I have no idea. Like, you haven't even given me data. This is all, purely hypothetical, like project planning. I have no idea what's going to happen 2 weeks from now because I haven't even, been able to train one model yet.
So I want to kind of switch gears real fast because we've been trying to create this new podcast with one of the community members, Fabiana, and we're talking to a lot of people about data access and how they go about that. And I find that is a really interesting problem to look at, especially once you start to get into larger organizations and you start to get into companies that are dealing with private information, or if you're working in the EU, for example, where there's all these regulations around the data. And then I heard horror stories about people waiting around for 6 months to get access to the data, and they're just kind of twiddling their thumbs until they get that access. And I'm wondering how you look at that problem and how you make sure that these horror stories don't happen, but you're also not super laxed on the data access so that anybody can have access to it.
Yeah, and I guess that's tough because there's also, there's ethical considerations there as well, right? I mean, it's from a data scientist perspective, you want to say like, oh, just like give me the data. It's not that big of a deal. Like, I'm just a person. Like, I should be able to access this, this regulated data with personal identifying information and work with it. But that shouldn't be the case. And we should have like very strict controls around that. And, consumers should understand and know what's happening with their data. It definitely comes down to that kind of governance problem again. The more like oversight and control and management you have of your data, the easier it is to safely provision access without, potentially damaging or lasting effects. It's not a space that I've had to work in like a lot. And like, well, I guess like, I've definitely seen it a lot in the healthcare space. But fortunately, it hasn't been my problem to deal with.
Yeah, I think the data access question is also interesting technically. And, I think this gets back to your thought kind of about platform in a slightly corollary way. These things, they tend to be built incrementally, right? It's nobody ever kind of goes out and says, hey, okay, design our data access system end to end. It's going to scale with us from 1 to 1,000 engineers and 1 to 100 data scientists. Boom, got to do it, right? And I think that's a challenge that I have a lot, is like figuring out what to implement now versus like what to implement later, particularly for a system like data access, where it's like you're thinking a lot about like interaction. Like, what's your interaction model with, let's say it's like an API, right? And some data science is just like pulling it in from an API, making some kind of request. Like, how do you go about designing that API model or like that interaction model? From your standpoint, how do you think about sort of like designing interfaces and kind of speccing out from a technical standpoint what the different use cases look like?
Yeah, I guess for me, it's just all about working with users as much as possible and understanding the use case. Like, I think it's as straightforward as just like get as many use cases as you can, real use cases, as quickly as possible, and try and work through them, because it's more than likely, that your first design and assumptions are going to be wrong in some way, shape, or form. Like building a platform for data scientists, like maybe you assume that they have some skill that they don't, or want some feature that they don't, or maybe it's not important at all, but you really need to get those use cases and understand them to actually correctly map out those requirements and design something that actually suits your needs.
Yeah, I think that makes total sense. It's you really have to have that empathy, that understanding, and that sort of like intuitiveness around the use case in order to be able to engineer the best way. Now I'm going to ask you a question, or a tough question. Have you ever had a case where, or does anything come to mind in terms of maybe where the use case wasn't very clearly defined on the part of the user? Maybe there was a little bit of incoherence or lack of process. And if so, how did you deal with that?
Yeah, absolutely. I think like more so as a data scientist than anything else, I probably had that right, because software engineering, I guess, is well defined. If you're building an application, there's, I mean, one, I guess the project managers and software engineers are very familiar with that. But so are probably consumers, right? It's something they interact with every day. Whereas I think when like ML and AI is kind of blowing up as a term, people started asking for those things without actually having a use case, right? Like I've definitely had cases of people coming to me being like, oh, like I want ML. And be like, great, like for what? And like, why? And like, is this even a use case that ML would be remotely good for? I think like actually being able to spot those use cases is like, so yeah, is a skill unto itself, right? Like seeing who is just asking for ML and who actually like has a problem that's currently tedious, manual, et cetera, that could be automated by some kind of machine learning.
You're totally right. That's the perfect example. It's totally perfect example.
Yeah. I was gonna try and steer this ship towards the idea of what you feel the next big thing is when it comes to machine learning, maybe beyond MLOps or within the MLOps ecosystem. Where do you feel the next big thing is?
I don't want to default on governance again, but I think it's going to be governance. I think it's going to be machine learning in the enterprise, actually like people seeing that it's driving value for certain companies. And it being kind of like getting up there, like, you know, you have data, like software, and now you're going to have kind of machine learning up there, I think, at the same time. I think it's that level of enterprise maturity that we're still not currently at, but some companies are starting to reach and really set a standard for. I think, you know, like obviously machine learning, like research in itself has been exploding for a really, really long time. But like the distribution of companies like using or getting value from machine learning is huge. You have some companies doing like real-time training online and like getting all these really great results from like real-time predictions. And you have some companies that are still probably questioning the value of ML itself and like whether or not like machine learning would, you know, they would actually get some kind of return on their investment for investing in the machine learning space so heavily. A lot of companies like to, you know, like stick a toe in the water, hire a data scientist, watch them burn out, and then nix everything. But yeah, I think it's going to be kind of a select few companies setting that standard of what machine learning looks like when it's actually driving value, and the rest of the market moving up to meet it.
Yeah, that's. I think that's spot on. I think that's something I really agree with, and I think it's something we see a lot in the community. You know, Etsy is one of those companies, DoorDash, Uber, certainly, you know, Facebook, Google, et cetera, Apple. They've been, you know, I actually think it's kind of interesting. I think the Facebook and the Googles and the Apples of the world, I think probably justifiably so because they're so big, but there's probably a little bit less about true MLOps stuff I've really learned from them. You know, I think it's more like the Spotify's, sort of like those mid-stage tech companies that have really given a lot of great lessons in terms of like, how does this stuff scale in like a modern way.
Yeah, and like a manageable way. Sometimes I feel like I read a paper from like a FANG company or something like that on their architecture or something, and I'm like, there's no way we're gonna implement this. Like this is like this is just like totally infeasible for wherever I'm at right now. But yeah, like
there's also something to be said. I think all of these companies are tech companies, and what it kind of sounds like you're saying, Kyle, is you're expecting more of the companies that aren't necessarily tech companies like your Coca-Cola's or Delta Airlines to also get up there.
Yeah, there's a huge difference, I guess, between the companies where data scientists are embedded in like engineering organizations, and like companies where like you have these siloed data science teams that are kind of unsupported from a lot of different standpoints. And maybe those data science teams are more so like the, you know, insights data science and stuff like that. Maybe they're working with marketing teams or otherwise. But like if they're data scientists that need to like create and deploy things to production that actually serve as the back ends for, you know, like software, then I think a lot of those companies like also have really cool things that they can and want to build to automate internal processes. but don't yet have the organizational structure or support for those data scientists to get to that level, or haven't organized in that way.
Yeah, I've actually, some companies that come to mind that, you may not think of as like awesome ML companies that I have actually been pretty impressed by are like Chick-fil-A, John Deere, some like, some those two come to mind. Those are
Shout
those
out
are the
to
two.
Corey, who's working.
Yeah, shout out to Corey, right? Yeah, no, I mean
the
those
community.
great companies that have really started to embrace ML and kind of bake it into their entire business model and their business sort of perspective.
Yeah, no, it's definitely out there, and that's not to say that like a non-tech company like is not like going to succeed at ML. But I think like there's like I think some of those companies are definitely doing it right. Your John Deere's are. It sounds like they're doing it right in terms of how they embed their data scientists in the organization and support they give them. And I mean, like, yeah, I guess there are a lot of companies that people don't think of as tech companies that are producing cool papers or interesting things within the machine learning space. But I guess like from the inside, I guess that I've seen in some of those companies, it can be difficult to get the support you need to get something into production, or even just to have like a senior engineer's eyes on something.
Yeah, I guess just to kind of maybe bring this discussion to a sort of close and just kind of get into our concluding period here. This idea of platform engineering, it's new. This idea even of like machine learning infrastructure, like what really is machine learning infrastructure? I think I've felt that a little bit lately. I think I understand, the importance of MLOps. I mean, I'm here hosting a podcast about it and hanging out on the community, and I see how this field has to evolve in a way that's probably a lot more like software engineering than maybe some of the more numerical fields that are out there, like signals and systems, etc. But I think sometimes one of the things I struggle with is really kind of defining what something like a machine learning infrastructure really looks like on a practical level at a company, right? It's kind of like, oh, these are our problems. Is it machine learning infrastructure? Is it DevOps? Is it, is it a software engineering issue? And I guess my question kind of to you is, have you dealt with similar challenge in terms of defining what the problems are that you need to work on? Or have you felt a little bit that, maybe because of the environments you've been in, it's been a little bit more clear? How do you think about that?
Yeah, it has depended based on like what the use case is for sure. I'm trying to think of the best way to answer that, because there have been times where I'm like, yeah, I'm like, what are we doing? Like, and I'm like, what is this here? Like, like sometimes I felt like I've just been following the flow. Like I'm deploying a model to a Kubernetes cluster because that's what people do. There's other times I've felt like I've been doing it because I need to do that. And like, I need, I need this 1,000 node cluster to scale up that high to actually serve the traffic that I'm trying to meet. And I don't know if I'm answering your question at all, but, but yeah, machine learning infrastructure is like, it's software infrastructure. It's all of the support that you need to actually support your ML software tooling at scale for your use case.
Yeah, I think you did answer my question, right? I think that Kubernetes example is a perfect example of something that we all feel like, oh man, we should be using Kubeflow, we should be using MLflow, all these things that are talked about, but it's like, what are the problems I'm trying to solve here? What are we really trying to do here? I mean, if you're asking yourself that question, I think maybe you are doing the job of a machine learning infrastructure or a platform engineering sort of contributor.
Yeah, there are definitely times where I've like, I started using Kubeflow and we were leveraging it way back at some other place, but it was like we started using it and we realized that we actually didn't need it. It was like kind of for our use case, it was too much. It was it was more difficult to manage than it was than like the value we're actually getting out of it. And we were like, we could literally have like for our small data science team, have a standalone deployment of MLflow and get everything we need like out of an MLOps pipeline, like without any kind of scale or management of like infrastructure resources whatsoever. Then there's other cases where that's just not even going to come close, and you have all these workflows running daily, and you need that kind of like a complex workflow orchestrator like that.
I know there's some kind of adage, but I can't think of it right now, where it's like you get the tool and then you look for the problem or something, as opposed to looking for the problem and then finding the right tool. But someone in the comments will help me out and remind me what adage that is, or what the saying is and how it goes. But this has been awesome, man. I appreciate you coming on here, talking with us. I want to mention to everyone that has stuck with us, Kyle, your team is hiring, right? And you've got a referral code. Are you still looking for
it's not
people?
directly my team, but the company's hiring a lot. Yeah. And I'm happy to provide, happy to speak to people in the MLOps community about whatever.
There we go. So if you're looking to work at Etsy, not making handmade baskets or any of that other cool stuff. I tried to sell stuff on Etsy once. That's a whole nother story. But if you're looking to work on the software team, then hit up Kyle in the Slack. And yeah, this has been awesome, man. I love hearing about your path. I love hearing about the vision that you have, and really diving into what are some core concerns, what are some ways that you can be a better machine learning platform engineer. And thank you.
Yeah, absolutely. Thank you so much for having me. I really appreciate the time, awesome questions, and the chat. It makes me think too. It's cool.
Yeah, thanks for coming on, Kyle. Really enjoyed it. I think our community, our listeners will get a lot from just some of the technical challenges you highlighted, all the different aspects. I feel like we really covered just how broad platform is when we talked about, okay, what are your consumers? What are the different interfaces? What are the different technical challenges? Like, this is a pretty broad field, and I'm very glad that you were able to come on. So thank you.
Yeah, of course. Yeah, no, and it's definitely massive. It's not like, there's so many different spaces you could get into and talk about. You talk about Kubernetes itself, for so many hours and hours. It'll like get into networking and like further and further away from the core. But yeah, no, it's been awesome. Thank you so much.